Hello students, in this session we will see Spearman's rank correlation coefficient. Spearman's rank correlation coefficient is a measure of statistical dependence between two variables. It assesses how well the relationship between two variables can be described using a monotonic function. A monotonic function is a function that is either always increasing or always decreasing on its domain. The correlation between ranks of the xi and rank between the yi, where the x and y are the variables. So this correlation between the xi and yi is called as the rank correlation coefficient. This method uses ranking of data rather than few data values. The importance is given to the ranking of the data rather than the data values, making it suitable when dealing with a ordinal or non-linear data. It makes it particularly useful when the data is ordinal or when the relationship between the variable is non-linear. This is denoted by using the symbol rho. The key points that we should remember about the Spearman's rank correlation coefficients are the monotonic relationship. So monotonic relationship is a relationship if as one variable increases, the other variable either consistently increases or consistently decreases, but not necessary at a constant rate. The next key point is the rank data. Spearman's correlation works by ranking the data points instead of using the raw data values as we have seen here. It will not uses the raw data values. So it assigns the rank to the values of the each variable. So these are the two important key points, and again we also say that the assumptions in the Spearman's rank correlation coefficient. Let's we see this how to calculate the Spearman's rank correlation coefficient. The formula used for calculation of the Spearman's rank correlation coefficient is given here. As you can see, rho is equals to 1 minus 6 summation of di square, where I equal to 1 to n divided by n in bracket n square minus 1. So rho is nothing but the Spearman's rank correlation coefficient. Small d is the difference between the ranks of the variables, and n is the number of observations. When there is the tie between the ranking, then we use this formula. As you can see, rho is equals to 1 minus 6 into summation of di square, where the I equal to 1 to n and plus f. So here we are adding the one correction factor. So this is used in the tie correction case. So divided by n into n square minus 1. So f is the correction factor, which is calculated as m into m square minus 1 divided by 12, where the m is the number of tied ranks within a group of data. So let me explain this in detail. So what is the tie correction, or what is the tie of the ranks? So in this data, as you can see, the x variables are given as 16, 15, 14, 16, 10, 16, 17. As we have seen that the Spearman's rank correlation coefficient uses the rank, not the raw data. So first we have to rank this data. When we start ranking this data, first we give the rank number 1 to this 17, because this is the highest value. And then after we give the rank number 2 to the 16. But here you can see that here are more than 116s are here, means the more than one data values are same. So that's why how to give the ranking. So we give the ranking as usual. So we give the ranking to the 16, 2, 3 and 4 here. So in this case, the 16 is repeated 3 times here. So that's why the value of the m is 3. The value of the m is 3 in this particularly example. Where again one more point that you should remember that here. So how many data values are repeated, okay, and how many times the data value is repeated. So these two important things you have to remember. So how many data values are repeated and how many times that data value is repeated. Here the only one data value is repeated in the x variable, that is the 16. So 16 is repeated 3 times. Again we see here the y variable. In case of a y variable, you can see here the 70 is repeated. Let's we start a ranking. So 86 is the highest number, so first we rank it. That is, this is the first. So after 86, so there is a 75 number, so its rank is 2. So then after 72 is there, its rank is 3. So then after there is a 71, its rank is 4, and 70's rank is 5, and here 6. So this correction factor you have to determine for the how many values are repeated in a data set. You have to consider the both the data set for which you are determining the Spearman's rank correlation coefficient. In a first data set, so one value is repeated 3 times. So that's why we have taken this. Okay. So again in second data set, the 2 times the value is repeated. So you will get the value of the f is equals to how many values are repeated. So total 2 values are repeated by considering this both the data set. In first data set, the one value is repeated, and in second data set also one value is repeated. So that's why here the f is equals to f1 plus f2. So for this, f1 is equals to m into m square minus 1 divided by 12, and f2 also you have to use the same formula. So we will get the values of the f as the f1 and f2 here. Okay, so here you will get the two f values. So make the addition of these two f values and put here, so that you will get the complete correction factor for the both the data. Let's we see the interpretation from the Spearman's rank correlation. If the Spearman's rank correlation coefficient is plus 1, so this is known as the variable increases, the other variable increases here. So the meaning of the plus 1 is so there is a strong correlation between these two variables, and this correlation is positive correlation. It means that as one variable increases, the other variable also increases. So minus 1. So this also indicate that there is a strong correlation between the two variables. So this is a negative correlation. The meaning of this is as one variable increases, the other variable decreases, and the zero value indicate that there is no correlation between the two ranks here. So in this way that we can interpret the Spearman's rank correlation. Let's we see the some steps involved in the Spearman's rank correlation coefficient calculation. So first step is the rank the data. First, whatever the data is given to you, first you have to rank that data. Assign the rank to the both the data variables. As we have seen that the data values are not used for the determination of the Spearman's rank correlation coefficient. We are using their ranks. If two or more data points are the same, means there is a tie between these two data points, as we have seen in the previous slide how there is a tie between the two data values. Here the 16, 16, 16. So these data values are repeated. So there is a tie between their ranks. So you have to assign the rank to them as our usual method and find out the average rank of these data values. Then assign the average of the rank that would have been assigned. So next step is the calculate the difference. So calculate the difference between the rank of the x and rank of the y. So these are the two variables. You have to find out the difference between the rank of the two variables. So third step is the square the rank differences. You have to make the square of their rank differences. So fourth step is sum the squared rank differences. Find out the summation of the squared rank differences, and then apply the formula and find out the Spearman's rank correlation coefficient. So in this, the critical stage is ranking the data and determining their rank. In case of a tie, you have to take the average of the ranks. Let's we see the one numerical on Spearman's rank correlation coefficient. So calculate rank correlation coefficient for the following data. Expenditure on advertisement is given here and the profit earned is also given. So expenditure on advertisement is given in the first row and profit is given in the second row. Let's we solve this numerical. The steps involved in solving the Spearman's rank correlation coefficient that we have seen. Let's we follow all these steps. First, you have to rank the data. So for that, you have to make even proper table. You have to put the both the variables in a separate column. So let's we put these variables. So x variable is in a first column and the y variable is in a second column. So now the x variable is nothing but the expenditure on the advertisement here. Let's we consider this expenditure on the advertisement as the x here, and profit, now I consider it as a y. So we have written this in a two separate columns. So first step is the find out the rank of the each data values for the each variable. So let's say consider the x variable and let's we rank this data values. So the highest value in the first column is 25. So its rank is 1. So next highest value is after 25 we will get 22. So its rank is 2. So after that there is 20. Its rank is 3. After 20, 15. Its rank is 4. So after 15, 14 is the next value. Its rank is 5. So there are more than one data values. Means that the 14 is more than one times. So let's we rank it. First, this is the raw ranking. So we rank it as a 5, 6, and for the next 14 we rank as a 7, and the smallest value is 10. So its rank will be 8. So please remember that here. So whatever the number of data points are there, your rank should be that much here. So this is the raw rank of the X. So first I am taking the raw rank for the better understanding. Later on you may skip this raw rank of the X and raw rank of the Y. You may directly find out the rank of the X and rank of the Y. So similarly, we give the ranking to the Y variable values. The highest value is the 40. So its rank is 1. The next value is 25. Its rank is 2. So again the 2, this 25 is repeated. It is a twice. So we give the rank to the next 25 as a 3. So then after, so 18 is there. Its rank is 4. After 18, so there is 12. 12 is there. So its rank is 5. So after 12, so next highest value is 10. Its rank is 6. After that 7, the rank of the 7 value is 7 and rank of the 6 value is 8. So in this way, first you have to complete the raw ranking. But as we have seen, if there is the tie in the ranking, as in a first variable here, you can see there is the tie for the 14 here. So value is same, but we have given the different ranks. But these ranks are not correct here. These are the raw ranks here. So as per the rule, we have to find out the average rank of the these data values. So you have to find out the average rank. So 7 plus 6 plus 5. So you first we find out the average rank of this. Okay. So these three values divided by 3 here, as there are the three values. So average we will get as a 6. The average rank of the 14 is 6. So first we write the average rank of this 6, 6, and 6. The rank of the other values will remain same, as that values are not repeated. So 8, 4, 1, 3, and 2. So this rank will, so this will be your final rank. So you have to consider these ranks for the calculation, or these are also known as the modified rank. So next, for the rank of the Y from the raw rank, we have to find out. As we have notice that there is the repetition of the data value. So 25 is repeated. So rank of the 25 is 3 plus 2. So 5 divided by 2, as the 2 times it is repeated. So the 5 divided by 2, we will get the 2.5. Its rank will be the 2.5. Here we write 2.5 first. Rank of the other values will remain same. There will not be any change in the non-repeated values. So we write it as it is. 1, 6, and 7. Now take the difference between these ranks here. So don't take the difference between these two ranks. Okay. So you may skip these two columns. Once you practice this, you may skip these two columns. Not necessary to take these raw ranks. You may directly find out this modified ranks. So then take the difference between these two values and then make the square of these values. So after that, you have to find out the summation of this d square. So here you will get the value summation of the d square after making the summation of this column. The formulas that are used for calculation of the Spearman's rank correlation coefficient is given here, the 6 into summation of di square, as we have calculated the value of the di square here. Okay, so you have to calculate it and put in this formula. The most important thing is the calculation of the f value or the correction factor in case of a tie. So we calculate this value as m into m square minus 1 divided by 12. As I told you, m is nothing but the number of times the data value is repeated. Okay, so here in first variable column, you can see that the 14 is repeated 3 times. You have to consider the how many times that is repeated. So 14 is repeated 3 times here. So again in second column also the value is repeated here. It means that you will get the two f values. I may take the addition of these two f values, so you will get the final f value. Let me explain this. First you have to find out the f1. So f1 is calculated as we know that the 14 is repeated 3 times. 3 into 3 square minus 1 divided by 12. So you will get the f1 value. So f2 is calculated as f2 equal to, so second variable is repeated 2 times here. Okay, 25 is repeated 2 times. So 2 into 2 square minus 1 divided by 12. You will get this value. And finally, the f is equals to f equal to f1 plus f2. In this way, you have to find out the value of the f here. So divided by n into n square minus n, where the n is equals to 8 number of data values. So this is the value of the n. Now we got the di square, f and n. So put the values in this formula and find out the value of the Spearman's rank correlation coefficient. Here I have given the answer also. Your final answer is minus 0.024. So this is the negative correlation. Okay, so there is the correlation between the expenditure on the advertisement and profit, but this correlation is negative correlation, means there is a negative association between the expenditure on advertisement and profit. Thank you for joining this session.